Hello and welcome to this video for demonstration of the OpenDayLight. So in this lab, we are going to install and download a little lab for OpenDayLight, and also we will build a small virtual lab using the Mininet and the obvious virtual switches which are being created inside the Mininet. And we will demonstrate how OpenDayLight will be able to communicate with Mininet and program the OpenFlow based OVS switches within the Mininet, and how it will enable the communication between the host, the virtual host within inside the Mininet. So those of you who are not familiar with Mininet is a small packaged environment, lab environment for testing of in general software-defined networking. So it consists of like a virtual image. You can deploy it, on any hypervisor, or you can just download it from the source. You can build it. So it uses Linux namespaces and OVS switches to create multiple virtual switches and create this virtual host within that, and allows the OpenDaylight or any other SDN controller to control the flows within those virtual switches using the OpenFlow. So in this video, we will go to the OpenDaylight website. We will download the OpenDaylight from there. We will put it on our machine, the machine which we have already prepared, the OpenDaylight machine, the virtual machine which we have. We will extract, run, and we'll also install the basic features on the OpenDaylight. So OpenDaylight, when it comes by default, the main features are not enabled. So we have to enable those features by calling the install feature on the OpenDaylight console to install and enable the specific features. Then we will access the OpenDaylight graphical user interface on the web interface, and from there we will be able to see and demo how the communication between the Mininet and OpenDaylight is going to be. We will also have our Mininets ready, set it up, and we will run the commands on Mininet to connect to the OpenDaylight, and we will have the demonstration that how the virtual networking within the Mininet, how it will get presented inside the OpenDaylight. So now to start with, let's go and start with downloading the OpenDaylight. Just going to my browser and browse to www.opendaylight.org. From here, as you can see, the latest version of OpenDaylight, the Flooring, has been released. We'll go to the download side, and from here we can download the versions of the OpenDaylight. Now, one small tip here is that this latest version of OpenDaylight, they don't have the maintained version of the web interface, the next UI or the deluxe web interface which OpenDaylight normally comes with. It has been removed from this latest versions, and so just to make sure that we get the web interface on the OpenDaylight, we go to older versions and we will download the Nitrogen version. So Nitrogen version is 0.7.0, so this one, and we will go for this one, the tar file. So I just copy the location of this file because I need to download it on this virtual machine, which is a different machine, and let's connect to this machine where we have here. So I just do a SSH to our ODL test machine, which is 192.168.211.113. I got the SSH keys, so I don't need to provide any login details. So I'm now just root at ODL 113. Now this is a CentOS version 7 virtual machine, which I have already installed the Java deployment kit, the JDK, and let's download the file which we just copied. Now let's get this downloaded. All right, so now as you can see, the file has been downloaded. So let's extract this file, which is this one, called tar.xef. So the package is getting uncompressed. All right, so we got the graph folder here. Now to start OpenDaylight, we just could call the from the bin folder within the graph, we call graph. So CROF is the wrapper over the OSGI, as I know, and that provides us some kind of user interface console to the OSGI platform where the whole OpenDaylight has been built in. Just give it a few seconds to start up. So the OpenDaylight is based on the OSGI platform. OSGI is a modular platform created by, I think, a few of the bigger organizations, and it supports loading and unloading of these different components, modulars. It's complete modular. You can load and unload different modules and plug into the OpenDaylight using the OSGI. Now, CROF is a wrapper over the OSGI's kind of interface that we use for communicating with OSGI. But in general, this is how the OpenDaylight and also the other SDN controller like ONOS, they are all set up and they work. Okay, so let's have a look at what's happening on this machine. So I open another console, the same to the OpenDaylight machine. Let's see what's going on. 211.113. Okay, so let's see. So so as you can see, our CPU cores are 100% utilized. So that is because of the Java. The Java is from starting the OpenDaylight, starting actually the OSGI and CROF. So we have to just need to give it some time for the full startup of the OpenDaylight once it's compiled. All right, so now as you can see, the OpenDaylight has been started. We can see this OpenDaylight ASCII logo here, and this is the command prompt of the CROF OpenDaylight user at root, and here we are at this stage. Let's have a look at what has happened. So as you can see, the process loads has been came down now. We are not highly utilized. If I do a netstat-pnl, let's see what this server now is listening on. It's okay. So here we can see two processes from Java, actually three of them. So one Java process listening at TC ports 46220. And we got another one on this port, and we have this one also on port number 8101. So this one actually is like a SSH connection. It's like a SSH server console to the CROF. So if you do SSH to this port, you will get here. That's the same console. But as you can see, it doesn't listen on anything else. So there is no web interface, nothing is there. And from here, we have to start giving the commands to do the basic installation of the OpenDaylight features. So here, for example, there are commands like, feature. So feature, if you do the feature list, it gives you all the possible components that you can install on this version of the OpenDaylight, the available packages which are packaged there within the OpenDaylight, within that package which we downloaded, but they are not activated. Okay, so the first thing first, let's do some feature installation. So the first one here, I have put it here, is the feature install OpenDaylight layer 2 switch. So this feature actually, it installs the layer 2 software within the OpenDaylight. So OpenDaylight, by default, everything in SDN is a program, right? So layer 2 switch is a program which defines that, hey, if I receive a packet from this particular port and I know, the destination MAC address, which I have learned already, so I know how to forward it. So this is a software which implements exactly the same logic of the very basic layer 2 switch. So whenever a packet arrives at one of our standard switch, physical switch or virtual switch, one of the ports, with the ODL, the layer 2 switch component, this software, it learns the MAC address, that it knows that, hey, this particular MAC address has came from this physical port or virtual port, so I'm going to learn that particular one. Don't worry about these errors, it's not issues right now. Now, the second component which we are going to install is this one. So this is all the packages that, installs the graphical user interface for us. So the Deluxe Core and deluxe apps, these are all related to the user interface of the OpenDaylight. So deluxe is the web interface of the OpenDaylight. So with this command, we will install all of those features here. Okay. Now this may take a little bit of time. Let's give it some time for doing it, do the installation. All right, so now let's see how the installation was done. So here we don't have much processes, and here we don't have anything. So the OpenDaylight has been restarted, and I think all the modules has been loaded. So checking that, you know, if those features which we install are working. Let's do a test. Call the netstat with NL, so we see the machine. Okay, all right, now as you can see, the machine is now listening on more ports, right? So we got port number 6633. So 6633 TCP is a port for the OpenFlow server, so that OpenDaylight layer 2 switch module which we installed, that's the software which is listening on port number 6633. So the OpenFlow switches, they will be able to communicate with OpenDaylight on this port. And also we got port number 8181, which is the web interface, the web GUI, deluxe web GUI of the OpenDaylight. So we should be able to access the ODL from here on this port from the browser. So let's get into our browser. We get a new tab here, and we call 192.168.211.113 port 8181, and remember we have to put index.html. Okay, here we go. So this is the login page of the OpenDaylight. Now we log in with admin, username admin, and default password is also admin. Okay, and this is the basic user interface of the OpenDaylight, as you can see. So here in the left side, we got a few of these, you can say, applications which we installed. So Yang Visualizer, the Yang UI, Yang Man, and we got also the topology. So the topology shows the topology which has been with the OpenDaylight actually can see. This probably as a default, or it was in the cache of the OpenDaylight. So now what we are going to do, we are going to, let's go back to our drawing. Yeah. So we are going to start our Mininet here, and we will connect our Mininet to communicate to the OpenDaylight. And that communication, as you could see, that, you know, it will be OpenFlow over the port number 6633 on the OpenDaylight. Okay. Now let's connect to our Mininet machine now. I will open a new tab here, and we do SSH as Mininet at sign 192.168.211. What's the last octet? The last octet is 55. So 55. Okay, the password of Mininet is Mininet. So you can download the Mininet from Mininet. I mean, you can download it as just a virtual appliance. You can load it on most of the supported hypervisor. Download the Mininet. So you can just download the virtual image, is what I have done. And you can run it on VMware, VirtualBox, Camo, KVM, and in my case, I'm running it on a Xen hypervisor. Okay, so this is what I have got, and let's go. So we got connected to our Mininet machine. So Mininet has a command called mn, which is the Mininet, and by default it just runs, you know, very basic. We need to call Mininet to create a little topology for us, and we will connect it to our SDN controller, which is the OpenDaylight. So once I call mn in Mininet and I specify the controller, which is a remote controller with the IP address of our OpenDaylight, and we specify a tree topology with 3 layers. Let me copy this command here. Okay. So what happened was creating a network, adding the controller, connecting to the remote controller 6653. So it uses port number 6653 to connect to the OpenFlow server on the OpenDaylight. It got connected. it created 8 virtual hosts within this server right now, and it created also 7 virtual switches, and it also created these links between the virtual switches and also between the virtual switches and virtual hosts. So for example, switch 1 is connected to switch 2, switch 1 is connected to switch 5, switch 2 is connected to switch 3, and for example here switch 3 is connected to host number 1. And so now we got 8 machines. One of the important commands in Mininet is ping command. So we can use the ping all command, which makes a full mesh pinging between all the hosts. So what happened here was host 1 was able to ping host 2, host 1 was able to ping host 3, and all the way down to host 8 to host 7. Now, if we go back to our OpenDaylight, and if I reload this, you see a new topology which has been loaded, right? So this is our current topology which we have. So we got different hosts. So you see host number 1, host number, sorry, this is one host, another host, there is no specific number, and these are all open flow switches which are all loaded here. So what happened was here in the Mininet, let me get another SSH to the Mininet. Let's see what was happening there. SSH to Mininet at 192.168.211.55 Mininet. Let's just do a process list. So we got OVS DB server, virtual switch D. We got the Mininet running in this machine, as you can see. If I do list of interfaces, you will see we got lots of interfaces on this machine, you know, for each switch, and also for, you know, these are the virtual connections between the switches and, you know, going to the to those hosts. Okay, and also from the Mininet we can call OVS commands. So OVS, here we go, virtual switch controller. So if we call show, sorry, I have to call it with sudo. This command, it shows us the virtual switches which has been created within the Mininet. So Mininet uses some scripts to call OVS to create all of these virtual switches. So here, for example, we got the bridge number 7. Bridge number 7 is connected to our SDN controller, which is our OpenDaylight, the controller. And here it is saying that, hey, I got this port, so port number 7 Ethernet 2, port number 7 Ethernet, switch number 7 Ethernet 3, and, you know, the other interfaces. We got another switch called, you know, switch 4, for example, here, and it got these different interfaces. So everything in Mininet is being implemented used with OVS, and OVS is being connected to the to our OpenDaylight. Now here, the reason that, you know, our hosts, they were able to ping each other was just because we loaded the layer 2 switch inside our OpenDaylight. So if you remember, when I added this feature, the install OBL layer 2 switch, this command actually enables this whole ping between all of our hosts. So the ping all command here, where we have all of the hosts are able to reach each other, is just because of the layer 2 switch software, the module which we loaded on our OpenDaylight. In general, you know, OpenDaylight has lots of features and project within that. So we just loaded, you know, this basic layer 2 switch to show you that, you know, how this works. But here behind the scene also, if I do a packet capture, for example, on the OpenDaylight server, you will be able to see that there are lots of packets, the OpenFlow packets coming from the Mininet, the OpenFlow packeting, for example, commands coming, being sent to the OpenDaylight. Hey, for example, on the switch 2, let's switch tree. When we send the command, ping command from the host 1, let's say, to host 2, the first time, you know, the packet will arrive at switch 3. So host 1 will try to send the command, send the ICMP packet to the host 2, but it will enter to the switch 3. Now inside the switch 3, the logic inside the OVS switch, it says that, oh, I got this packet, is from host number 1, it is going somewhere that I don't know, what should I have to do? So it sends this packet back to the OpenDayLight, and OpenDayLight, it will pass that packet to the layer 2 switch module which we have loaded. So then layer 2 module software, then it knows that, oh, this packet has come from here. Let me find out, you know, where is the host number 2, and if host number 2 has got some information, you know, it has received some information from the other switches, other virtual switches, it will be able to pass it through, you know, another switch. So it will there, for example, if this is the host 1 and this is the host 2 here, the first time the packet will arrive at this switch, and the OpenDayLight will tell the switch, hey, you have to send this packet to on this port, which will arrive at the switch number 2, for example. And once the packet comes here, again, this switch will ask OpenDayLight, will say that, hey, I got this packet, it's going from this MAC address to this MAC address, I don't know what to do. And OpenDayLight again programs this switch that, okay, you have to send this packet over this interface to the port switch number 3, and the same happens here, where the packet finally ends into the destination host. You know, OpenDayLight has lots of other components and features. You know, the protocols, for example, you can run BGP, BGP PCEP, you know, as a southbound protocol. Also, you have all of these northbound APIs which you can communicate with OpenDayLight. You can extract all of this information as XML, JSON, or whatever else from the OpenDayLight. So, so this was all about our today's demo about the OpenDayLight. I hope you enjoyed it, and if you have any question, please write your question in the forum, or you can contact me directly if you need any more clarification or you need any specific demonstration of a specific project inside the OpenDayLight. Thank you.